goes, I think. There we are. Recording has started. All right, we're on 6-5. It's titled Right Triangles. It's on page 251A in Braille, page 251 in print, and there is a definition. This is familiar stuff. We've already kind of defined triangles. Now we're just going to get into the theorems of them, and there's some really kind of fun abbreviated theorems throughout this section that we kind of want to put to memory. They should make sense, and then you can use them for your arguments, for your proofs when you're doing some things. At the very top it should say, in a right triangle, the side opposite the right angle is called the hypotenuse. The two sides that form the right angle are called the legs. And then there's a graphic in the midst of your page of a right triangle. They have not labeled the vertexes, so it's just the outline of a right triangle. But they are labeling the hypotenuse and the legs. So there is a top vertex that goes from 12 o'clock to 6 o'clock on the right, and then a bottom base, and then there is a right angle indicator down there at the bottom right, the interior of your triangle, and then directly opposite that right angle indicator is the long side of a right triangle, and they've labeled that the hypotenuse.
So hypotenuse is the base, or what?
No, the hypotenuse is the side opposite the 90-degree angle. Always, always, always. It's the side opposite the 90-degree angle. It's the longest side of a right triangle. It's called the hypotenuse. And then the two shorter sides that come together to form the right angle, those are called the legs. So on an isosceles triangle, recall that the two congruent sides are called legs, and they form the vertex angle. On a right triangle, the two sides that come together to form the right angle are called the legs, and the side opposite the right angle is the hypotenuse. Remember back several sections ago, a chapter or so ago, when we were talking about triangles, we noticed that the sides corresponded to the measures of the angles. So the largest side was always opposite the largest angle. And in a right triangle, your largest angle is always going to be your 90-degree angle, because you're going to split the leftover 90 degrees between the other two angles. You also learned that those other two angles will be acute, and you're going to split up the 90-degree angle because of the Angle Sum Theorem. 90 degrees is all that's left. So notice then, even on this, even though they haven't indicated the measures of the angles, the bottom left vertex angle, the side opposite is the shortest leg, isn't it? And it's the smallest angle, isn't it? And then the top little vertex angle, it's a little bit bigger, and the side opposite, that leg is the middle side. All right? The hypotenuse is always, always, always the longest side and the side opposite the 90-degree angle. And that's very important to remember, because we're going to review, you've already learned this theorem, the Pythagorean theorem. We're going to review the Pythagorean theorem and apply it in the next section. So turn your Braille page. Print users, your one section down. And turn your brain on too, yes. All right, we're on 251B in Braille. It should say up at the top, in triangles ABC and DEF, the two right angles are congruent. Also, the corresponding legs are congruent. So the triangles are congruent by side, angle, side. Remember SAS?
Mm-hmm.
Yeah. So they're just showing it in this particular right angle comparison. So you have two small triangles in the midst of your Braille page. The one on the left has the top left vertex labeled A. The bottom left vertex is B. And the bottom right vertex is C. And then you make your way back to A along that hypotenuse. At vertex B is a right angle indicator. On leg AB, on the left, there's one tick mark and on leg BC, there's 2 tick marks. So that's showing nothing by itself. That's just showing that all 3 sides, this is a scalene right triangle, correct? All 3 sides are different. But if you go immediately to the right, you're going to find triangle DEF. The top left vertex is D, the bottom left vertex is E, and the bottom right vertex is F, and then you make your way back to D along the hypotenuse. At vertex E is a right angle indicator, and then from D to E, that leg has 1 tick mark, and from E to F, that leg has 2 tick marks. So then you go, oh, okay, between these 2 triangles, they're showing me that AB on the left triangle with 1 tick mark is congruent to DE on the left with 1 tick mark. My 90-degree angle indicators, that's showing congruency. 90 equals 90 at vertex B on the left and vertex E on the right. And then leg BC on the left triangle has 2 tick marks, and leg EF on the right has 2 tick marks. That's showing those 2 legs are congruent. So you kick your brain on, turn your brain on when we learned about SAS and angle, side, and sides. Remember all those? We have an SAS here, don't we? We have a side, angle, side. We have an included angle between 2 congruent sides. So these two triangles are congruent. So it then talks about we have a special situation going on here with right triangles. So down below in Braille, below your drawings, your tactiles, and then down below the drawings in print, it says, since right triangles are special cases of triangles, the SAS test for congruence can be used to establish the following theorem. All right, so we have a new theorem, theorem 6-6. And on the next page, we have Braille page 251C, theorem 6-6, the LL theorem, right? LL theorem, capital L, capital L. And it says in words, if 2 legs of one right triangle are congruent to the corresponding legs of another right triangle, then the triangles are congruent. We don't have to say side, angle, side. We could just go, oh, those are right angles and both legs are congruent, so I know it's congruent. Because they're right triangles, you are always going to have that right angle be congruent to each other. So you don't have to say side, angle, side. You just get to go, oh, leg. Both legs are congruent. I know that these 2 triangles are going to be congruent. Right?
Yep.
So you get to go one step further with the right triangle, and it has its own special theorem. And it just shows the same triangles again, triangle ABC on the left and triangle DEF on the right. And it shows the leg AB is congruent to the leg CE, and the leg BC has tick marks and is congruent to the leg EF, and then you have your right angle indicators at vertex B and E. And now this is just LL theorem, leg. The LOL, in Braille, little theorem, right? Isn't LL little? Yeah. It's the little theorem, the little legs. All right. Turn the page, and we're going to talk about another theorem. So it says, suppose, this is on 251D, suppose the hypotenuse and an acute angle of the triangle on the left are congruent to the hypotenuse and an acute angle of the triangle on the right. So it shows drawings at the very bottom of print page 251. In the middle of this 251D, we have another triangle, ABC. Looks very familiar to the last one, except they're going to show some tick marks in a different orientation. So A is the top left, B is the bottom left, C is the bottom right. At vertex B is our right angle indicator. At vertex C is a tick arc going through the vertex. And at the hypotenuse, A to C, they have one tick mark. If you go immediately to the right, to the triangle to the right, DEF, you have D at the top left, E at the bottom left, F at the bottom right, and back to D, top left. Again, we have a right angle indicator at vertex E. We have from D to F, we have a tick mark at the hypotenuse. At vertex F, we have one tick arc. Vertex F, one tick arc. So congruency is being shown on the hypotenuses with the tick marks, and at the vertex angle, the little acute angles C and F. So think back to your congruency statement from a couple of chapters ago. What do we have going on here? So we have 90 degrees and 90 degrees. That's one angle, right?
Mm-hmm.
We have angle C and angle F. That's another angle they're showing congruency. And then we have side AC and side DF. So we have angle, side, don't we? Okay, so we know without even having a new theorem that we could use angle, side as, remember that one, angle, side? We could use that one to state congruency between these two triangles. But we start turning our brain on about right triangles, and we know that we're always going to have a 90 and a 90. So, if I have a hypotenuse and my acute angle, I know I'm going to always have congruent triangles. So that's the next theorem. If you turn the Braille page to 252 and the print page to 252, theorem 6-7 is the Ha theorem. Ha. We have the little theorem and the Ha theorem. HA, hypotenuse and acute angle. So it says in words, if the hypotenuse and acute angle of one right triangle are congruent to the hypotenuse and corresponding angle of another right triangle, then the triangles are congruent. So either of the, what's showing you on these two drawings is it can be either acute angle. It doesn't have to be that little base one. It could be the other one, because you're still going to have angle, side, regardless of which one it is. So you just need one of the acute angles to be congruent to the other at one, and then the hypotenuse. So Ha, hypotenuse and acute angle. So they have two little teeny drawings in the midst of your Braille page. They have drawing A, B, C, triangle ABC on the left. A is the top left, B is the bottom left, C is the bottom right. We get our way back to A again. At vertex A, there's a tick arc. So top left, there's a tick arc. At vertex B, we have our right angle indicator. And at our hypotenuse, the side opposite the 90-degree angle, there's one tick mark. AC has a tick mark. Go immediately to the right to triangle DEF. D is at the top left. You with us, Jess?
Yeah.
D is at the top left. E is at the bottom left. F is at the bottom right. Back up to D. There's an outline of your right triangle. They have a tick arc at D, so your brain goes, aha. A and D are congruent. 90-degree angle at E. I've got two right triangles. That shows congruency between B and E. And then from D to F, the side opposite E, your hypotenuse has one tick mark. Ah, the hypotenuses are congruent. Therefore, I can use the Ha theorem. All right, hypotenuse and an acute angle, knowing that these two are congruent.
But they have a leg. So
Where? What? They do have legs, but they're not. They didn't put tick marks through them. But because they put a tick mark through AC and DF, we know that AB and EF are congruent also. Yep, everything's congruent. They just didn't have to put tick marks through everything, because we're going to say by the Ha theorem that these triangles are congruent. So all sides, all angles are congruent, just by knowing that the hypotenuse and one of the acute angles is congruent. All right? Okay, turn the page, Braille page. Print users were in the midst of 252. Braille users, you're on 252A. Now we got to start proving the next theorem and postulate. 252A. So it says up at the top, suppose a leg and an acute angle of one triangle are congruent to the corresponding leg and acute angle of another triangle. So now we did the hypotenuse and the acute angle. Now we're going to test out a leg and acute angle. So we have case 1, where it's showing us the leg is included between the acute angle and the right angle. So we have two triangles under case 1. We have triangle ABC on above triangle DEF. A is top left, B is bottom left, C is bottom right. There's a right angle indicator at vertex B. There is a tick arc at vertex A and a tick mark on the leg side AB. So we have an acute angle, the side, and our right angle indicator. The brain turns on and thinks about your triangle congruency theorems from a couple chapters ago. What do we have showing here so far?
Angle.
Angle, side, angle. Good job, Angelica. So then we go down to DEF, just below triangle ABC. D is at the top left. E is at the bottom left vertex. F is at the bottom right, and go all the way back up to D. At vertex D is a tick arc. At vertex E is a right angle indicator. And on leg DE, side DE, there's one tick mark. So there we are, angle, side, angle. So case 1 uses angle, side, angle. Let's try the next. So we have a leg and an acute angle being proven by angle, side, angle, correct? So something might be happening here. We have a LL theorem, a Ha theorem, and now we have a leg and an acute angle. I think we might be coming up with a law theorem, right? LA? All right, let's look at case 2 and see if it'll work with case 2. So that was one of the legs. Now let's take a look and see if the other leg proves it. So case 2 on the next page, 252B, and immediately to the right in print, we have our two triangles again, one on top of each other, A, B, and C. A is top left, B is bottom left, C is bottom right. Back to A again. At vertex A, there's a tick arc. At vertex B, there's a 90-degree indicator. And then on leg BC, they have one tick mark. Now what congruency triangle statement are we going to use?
Angle, angle, side?
Yes, Stormy. Angle, angle, side. Are you going to be a lawyer, Stormy? Think about it. So D is your triangle directly below. You have DEF. D is top left. E is bottom left vertex, and F is bottom right. And then all the way back up to D again along that hypotenuse. At vertex D is a tick arc. At vertex E is our 90-degree angle indicator. And from E to F is one tick mark. There it is, angle, angle, side. So both cases use one of our congruency statements from before. The first case used angle, side, angle. And this one uses angle, angle, side, but where they have a commonality is they both are using an acute angle and they're both using a leg. So that brings us to the next theorem that we can say we have a law theorem, an LA theorem. So we have LL, the little theorem. We have the Ha theorem, HA, hypotenuse acute angle, and then we have
The
Los Angeles theorem, the leg acute angle. Now we don't, so if you turn the page, that's theorem 6-8 on Braille page 252C, and then we're about halfway through our print page on 252. So theorem 6-8, in words, if one leg and an acute angle of a right triangle are congruent to the corresponding leg and angle of another right triangle, then the triangles are congruent. So it's LA, leg and angle. All we got to do is find a leg and an angle, because we're always going to have that 90-degree angle. So it shows it again with a drawing a model, triangle ABC on the left, and triangle DEF on the right. A is top left, B is bottom left, C is bottom right. At B is our right angle indicator. At vertex C is a tick arc. So they switched it up on this one and showed you that it doesn't matter which acute angle you use as long as they correspond with the other triangle. So they're using vertex C. A to B has a tick mark. So there's that leg, and there's an acute angle. So now we have law, leg angle, right? And then DEF on the right. At E is your right angle indicator. D to E on the left is one tick mark, and at F is a tick arc. So there's a leg and an angle. Right? So therefore, triangle ABC is congruent to triangle DEF because of the law theorem. Turn the page, and we have a postulate. I'm going to talk about the postulate, and then the next page will show the model. So on page 252D, it says the following postulate describes the congruence of two right triangles when the hypotenuse and a leg of the two triangles are congruent. So then you turn the page, and on 252E, we have the HL postulate. So now we've covered all our bases. We have leg, LL. We have HA, hypotenuse and acute angle. We have LA, leg and acute angle. And now we even can use hypotenuse leg, because you're going to see, you're going to put your brain on and go, oh, I get what's going on here. So it says, if the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and corresponding leg of another right triangle, then the triangles are congruent. So it shows triangle ABC on the left. Same orientation each time. That's what I like about this chapter, is they just kept your triangles going each time in the same direction, didn't they? Mm-hmm. So it makes it very simple to make our way through these. From A to B, there's two tick marks. At B, there is an angle, a right angle indicator, and our hypotenuse has one tick mark. And then D, E, and F, they have two tick marks from D to E, and one tick mark from D to F. So we just have to have a leg and a leg and a hypotenuse and a hypotenuse, and we get to use the hypotenuse leg postulate to prove congruency. And the reason that happens is that if one leg is congruent and the hypotenuse is congruent, well, then what's left over is that other leg, and it's got to be congruent in order to make up that triangle with that right angle there. So then we end up with a side-side-side situation if we really wanted to draw it all out. And so instead of saying side-side-side, all we have to do is look at the hypotenuse and the leg. All right? So now it's all bases are covered. So if you see two right triangles together, all you got to do is look for LL, LA, HL, or HA.
Oh, this is HL then.
This is HL. That's right. This is HL. Okay? So let's go determine that. Let's go be a lawyer. Let's go be a geometry attorney. and prove the next few drawings as to why they are congruent. Not just because it says so, right? Okay. So there's a page break on the next page. It's 252F, and then there's a page break about 1, 2, 3, 4 lines down, and we are on 253. Print users right at the top of page 253. So in the examples, it says determine whether each pair of right triangles is congruent by LL, HA, LA, or HL. If it is not possible to prove that they are congruent, write not possible. So example 1 shows two triangles. It looks like they have done a rotation and a reflection on this, doesn't it? To kind of remind us of the transformations going on here. On the left, you have triangle D, E, and F. D is the top left, E is the bottom left, and F is the bottom right. And then we go back up to D again. At vertex D, there's one tick arc, and at vertex E, there's a right angle indicator, and then the leg DE on the left has one tick mark. So your brain should be kicking in. It should be saying, okay, I've got a right triangle. They're showing me an acute angle and a leg. So I should be thinking about what theorem?
LA?
LA. So let's go make sure that on my right triangle next to it that I've got LA with corresponding parts, right? That's the important thing, is we got to have corresponding parts. So notice they make you think on this one. They flipped the triangle over and slid it a little bit, didn't they?
Mm-hmm.
So we have triangle, if we start on the top left, R, and then we go immediately to the right, to the top right, S, and then down to the bottom right, T, and then we go back to R again. At vertex R is a tick arc, RS is a tick mark, and at vertex S is your 90-degree angle indicator. So what you have to do is be very careful about realizing, do the parts correspond, correct? So we know S and E correspond, so they're both right triangles. We got to make sure that vertex D corresponds to vertex R, don't we? Yeah?
Yep.
So if we flipped it over, it does, doesn't it?
Yes.
Because D and E is the short side, isn't it, to R and S? So it does.
Yep.
But you have to think about the triangle flipping over and sliding, don't you? Kind of sliding in order to match up. That's the tricky part. Because they might have marked ST, and then you'd be like, wait a minute, that does not correspond with DE. I'm in trouble here. All right?
So
Okay.
then it would be not possible.
So it wouldn't be possible. But this one is because of law, isn't it? And because we made sure that the sides correspond and the vertexes correspond. All right. Number 2 is on the next page, Braille page, immediately to the right in print. We have 2 triangles in the midst of the page. At the top of that page, it explains why the previous 2 triangles were congruent. It just says there's one pair of congruent acute angles, angle D and angle R. There's one pair of congruent legs, angle or side DE and side RS. So triangle DEF is congruent to triangle RST by law, LA. All right. In example 2, we have a triangle on the left. X is the top vertex. And then we go all the way down to the bottom left, which is Y. Y. And then we go immediately to the right to vertex Z, and then back up to vertex F up at the top again. At vertex Y is a 90-degree angle indicator. The leg YZ has one congruency tick mark, and the hypotenuse XZ has 2 tick marks. So We notice it's a right triangle, and then what do we notice? We have a hypotenuse and a leg showing.
HL.
So we might have HL here, right?
Yeah.
Now we got to make sure that the triangle immediately to the right, those parts correspond. So we go immediately to the right. It looks like they've done a bit of a rotation here on us. We have point M at the top left. Go immediately east to point N at the top right, and then south to point P at the bottom right, and then back to M again for your hypotenuse. At vertex N is a 90-degree angle indicator. Leg NP has 1 tick mark, and hypotenuse MP has 2 tick marks. So do these correspond? Well, the 90s correspond for sure, but we don't care about those. We want to make sure, okay, bottom, the smallest leg, aha, yes, YZ does correspond with NP, doesn't it? And then our hypotenuse always corresponds. So are these two triangles congruent?
Yes.
Yes. And why are they, Counselor Rose? Why are these two triangles congruent?
They, I believe, as in,
Okay. Counselor Griffith, will you help out co-counselor Rose? Why are these two triangles congruent? The HL theorem, yes, because of the hypotenuse leg theorem. Exactly. Excellent. And it does say that down below, doesn't it? It says there is one pair of congruent legs. YZ is congruent to NP. And the hypotenuses, the hypotenuses are congruent XZ to MP. So triangle XYZ is congruent to triangle MMP by HL, hypotenuse leg. All right, your turn on the next page. You need to be geometry attorneys here. You can't just say yes or no. You have to say why. And if they are not, you have to say not possible. So we have two problems on this page. Two triangles up in the top half. We're on 253B. In print, you're right in the middle of your page on the Your Turn section. You with us, Jess?
Yep.
All right. So we have a triangle on little letter A. We have F at the top left. Go immediately to the right to H. And then at the bottom left, you have G. And then G to H connect. There's a right angle indicator at vertex F. FH has 1 tick mark. FG has 2 tick marks. Move immediately to the right of your drawing. And there's some sort of rotation and slide going on here. We have triangle, we have at the top left M. At the bottom left vertex we have J. And at the bottom right vertex we have K. We go back up to M again. Through MJ is 1 tick mark. At vertex J is a right angle indicator. And through JK are 2 tick marks. Are these two triangles congruent? If so, why?
yeah,
I get Counselor Griffith saying they're congruent. I get Counselor Rose saying they're congruent.
Yes.
Counselor Walker says they're congruent. Counselor Spong?
Yes.
Yes. Counselor Rupp? We're on 253B. You're just going along with your co-counselors. All right. Counselor Walker, please prove to us, please argue for us why these two triangles are congruent.
Because of the Is it the HA theorem?
HA theorem, no. It's not a hypotenuse or an acute angle.
It's a leg.
Counselor Griffith, what?
Leg.
Leg, yes. Leg theorem. Because we have angle side, side angle side going on if it was not right triangles, and the both legs are congruent to each other, so it's the leg, the little theorem. Counselor Spong, do you concur?
Yes.
All right. Little letter B down below is your next example that you need to get through, and will probably take us through to the bell. We have a big triangle kind of being split up into two triangles, don't we? We've got some sort of bisector going on here, which you learned about in the last section. We have X at the top left, Y at the bottom left, and Z all the way over to the right. Thanks, Rahel, yeah. From vertex Z, there is a line going through the midst of our triangle perpendicular to XY. We have two right angle indicators to both sides of that line, and that's at the point W. So there's two right triangles going on here, isn't there?
Mm-hmm.
Yeah. XWZ and YWZ, and we have a right angle indicator. There are no tick marks anywhere. So are these two right triangles congruent to each other?
No.
No.
It's not possible.
It's not possible. We don't know. It looks like maybe it might be by the drawing, but they didn't tell us that any of the sides were congruent to each other, did they? They could be teensy bitsy off. It might look like they are. Don't say it looks like they are, ever. In math, we don't say it looks like, right? We say the measurements, or we say they're congruent, or we prove, we show it. We don't go, oh, well, it sort of looks like they are.
It is or it isn't.
Yes. So we only have these two right angles that are congruent. There's no theorem. There's no angle theorem on right. It's got to have some sort of side involved, either the hypotenuse or a leg or both of them. Okay, so it's not possible. All right.
And there's no SS either.
There is no SS. Your task is to take one of the problems either on page 253 or 254 and prove it. I don't want to know it's congruent. I want to know why. All right? That should be very simple. All right? Prove why one of the problems on either page 253 or 254 is congruent or not. All right? We will see you in the morning.
Okay.